way back in time, to the end of the 18th century. And then, of course, through Einstein's general relativity, we had the tools to actually start to describe these objects for real. But since the mathematics is so complicated, it took several decades before one really was able to understand what's going on. Could such objects actually form in the real world? And that is what Roger Penrose did.
Welcome to Hidden Access. It's a place where you can waste your time on the internet. Welcome to the club.
The Academy of Sciences has today decided to award the 2020 Nobel Prize in Physics with one half to Roger Penrose for the discovery that black hole formation is a robust prediction of the general theory of relativity. And the other half jointly to Genzel and Ghez and Reinhard Genzel for the discovery of a supermassive compact object at the center of our galaxy. Roger Penrose was born in Colwich in England and got his PhD at Cambridge University. He's now emeritus professor in mathematics at the University of Oxford. Reinhard Genzel was born in Bad Homburg vor der Höhe in Germany. He got his PhD at the Universität Bonn and he's currently director at the Max Planck Institute for Extraterrestrial Physics in Garching in Bayern in Germany. And he's also a professor at the University of California at Berkeley in the United States. Genzel and Ghez, finally, was born in New York City. She got her PhD at Caltech in Pasadena in California, and she's currently professor at the University of California, Los Angeles in the United States. Now, we are not requesting that the Nobel laureates come to Stockholm in December this year to pick up their prizes. Because of the pandemic, we plan for digital Nobel lectures and a digital prize ceremony with laureates participating over video links. We are still working on these events together with the Nobel Foundation and, of course, from now on with the laureates themselves. And we'll come back with more information as soon as it becomes available.
Now, a black hole a little bit more closely. In general relativity, there's an intimate relation between gravity and time. Down at my feet, time runs 1/trillionth of a second slower per hour than it does up in my head. And if you have a black hole, time even seems to stand still at the horizon of the black hole. Now, I can point towards the black hole and say, there it is. There is the center of the black hole. My finger is stretched along a direction of space. But if I then bring my finger a little bit closer and let the tip of my finger go through the horizon and enter into the interior of the black hole, I will make a startling and somewhat worrying discovery. The direction inwards is now time, and the tip of my finger will be in my far future. And it will be as difficult to pull my finger back out again as it would be to travel backwards in time. Furthermore, my finger will be torn apart, and the tip of my finger will be carried by time all the way into the center of the black hole, where time itself ends, and the known laws of physics cease to apply. But if such objects now actually exist in the real universe, then how could you find them? Well, actually, already in 1783, John Mitchell had an idea. What if what if there are other luminous objects, such as stars, moving around the black hole? Then one could infer the existence of the black hole by following the motions of the stars. But it would take more than 200 years before this dream would come true. And it was Reinhard Genzel, Genzel and Ghez, and their teams who did it. They turned their telescopes towards the center of our galaxy, 26,000 light years away, where there were suspicions that something strange was going on. The heart of our galaxy, the heart of the Milky Way, is hidden inside of a dense cloud of dust. And you have to look in the infrared to reveal its secrets. What they found was incredible. They could see several stars moving around something that they couldn't see. And it was one star in particular that caught their attention. It took the star around 16 years to complete its orbit. At closest approach, it was no more than 17 light hours away from the invisible object. Calculations show that 4 million solar masses is hiding there. There is no other explanation than a supermassive black hole. This year's laureates have uncovered secrets in the darkest corner of our universe. But this is not just an old adventure coming to its triumphant conclusion. It's a new one beginning. As we probe ever closer to the horizons of the black holes, nature might have new surprises in store.